Hi, welcome to another video and episode on my Arduino Mega2560 using pulse width modulation in combination with quite a few electronic parts. Last time I changed my algorithm from using the eraser and then the prescaler to using some value of the 0 register bitwise and with this value bitwise or with this value, which is by the way 5, and this is 1024 minus 5, you do the math, and this would give 1024 for 61 kilohertz. The measurement showed 6, and I assume that is good for 61.04. However, some calculation showed that with this unknown value I don't quite get how they get to 1024. Well, you can do simple arithmetics, but even then you have to make some assumptions. Now the point is that with the motors I'm using for pulse width modulation, the useful range for me is 40 to 120 Hz, or as it has turned out, I can also use 30 Hz. With 60 being in the lower range of 40 to 120, I can try to use the next higher frequency, but that isn't 120, that is 244. To make sure that everything is measurable, I am going to do that anyway. So I am copying this line and I'm putting it one above and say, okay, according to the data I have, this makes sure that it is the setting 256, which would give 244.14 Hertz. So the question is, will this indeed work? Now if I look at the motors, then they are being controlled by pin 2 and pin 4, and that is one of these. So this means that at least one of the motors is controlled by this. Another point is that it has shown that pin 13 is delivering a much higher frequency than pin 4. I haven't yet found out if that is actually a hardware problem or whatever, but apart from that, I am just going to find out how this works and uploading it and see whatever happens. So actually this should mean that one of the motors will cease operating, but I will see. First uploading and measuring. And yes, the motor that is affected is standing still actually. No, it is running again. It needs a bit of a manual touch. So let's see. So I have changed the frequency to 244 Hertz, and that is with this white cable. So I'm measuring right here now, and I see it is 250. That is yeah, if you round it, it is quite acceptable. Now let's turn our attention to the motor, because it is this motor that is affected. And as you can see, at 244 Hertz it is actually running. So this gives also the question, just and as in the past, 40 to 120, 30 works, but 240 is quite a lot higher, actually double of 120. So how come it does work? If I go measuring the voltage, I will get 5 volts, because that is what this board delivers. So would it be then a combination of from Vistechnic motors, 9 volts and maximum of 120 Hertz, and this is lower voltage, so it can get a higher frequency? Possibly. I can check on that, by the way, because if I go to 64, I would get nearly a kilohertz. So would it run then as well? I can just check out. So off camera I will check the code, change the code. And uploading. Then giving a little push. So going back here, well, the motor is running. What am I looking at here? 1 kilohertz. And the motor is still running. So this means how far can I go? Under 30 Hertz it proved a total quiet. For the motor, that is. I could check more, but is that of any use? Not quite sure. Let's go check on the wire 13, because that is still a problem. Not that I really need it, but I want it just to work. So once again, let's check. Yes, 1 kilohertz, way above the 120 I'm looking at, but oh well. Then for security, let's check this one as well, and this is still at 30 Hertz, and that is the right side motor. So to be perfectly sure, that is the motor at the left side, at the right hand side, still at 30 Hertz. Anyway, back to code. Alright, so now I have proven that with a frequency of, and let me change this appropriately, 976.56 Hertz, it does work. Now what I want to know is, can I reach 60 something lower here? That should be possible, since I could reach it earlier. So I'm going to do that, and yes, here I already set it, so let me uncomment this one. From the original documentation I found this not entirely true. This was the latest setting. So I am adding now this one myself, and by factor 8 this should be the next. But the question is this something like say 30 Hertz? And that is a very good question, because 100 is, as said, a factor 4 lower, but a higher frequency. So what would this be? The only thing I can do, because I haven't figured out, without knowing this, the real value of the 0 register, I can't really figure out how this works, so I need to check it out, and I will do so right away. And what I notice is that the motor does not respond to my touch. So I am going to check on the frequency, and it says 450 Hertz, around, kind of 450 Hertz right now. Doesn't make sense. And this is still port 4. So still measuring. Yes, around 400 Hertz. But the motor does not want to start. So I'm going back here, upload, and mind, this is just one value change. So does the motor respond? Yes, the motor does respond. And what do we have as value? 60 Hertz. So Unfortunately, this means that this using is no use at all. Not working. Well, the motor it does work, but the motor won't start. That's a big difference. Motor won't start. So where can I go now? I can test higher. So this actually is the lowest or highest value that you can get. That is working. Now I know that this is working. The question is when I go to 1. So I do copy this, and then I have to change this value to 1. So now I have 4 zeros and 1 1. I am setting this to 1 for a frequency of no less than 60 to 500 Hertz. Yeah, so actually 62.5 kilohertz. The question is, will this let the motor work as well? Only one thing I can do, test it. So that's exactly what I'm going to do now. Giving the motor another push. It does work, and it is on a frequency of 60 Hertz. Oh yeah, right, wait. Oh, I forgot to comment this. So now I have disabled the 60 Hertz. And still the motor works. What frequency? Yes, I have to scale up to a range of 200 kilohertz on the multimeter. And indeed it says 63.6. So a little bit higher than in the documentation says. But the motor does work. And I can, let me show you on camera, because talking is nice, but if you see it, it's always nicer. So yeah, let me do that. So proven that lowest value is 62.5 kilohertz, and as you can also see, let me actually show you on the multimeter. This is the 20 kilohertz setting, and this is the 200 kilohertz setting. So for the 62 I have to set it here. Alright, back here, and still the 4 wire, and oops, you can barely, now you can't see it on the screen, now you can. This is giving 63,700 kilohertz. So this is slightly higher than in the documentation. I don't know why this is different than documentation, but it might be a fair calculation within the multimeter. I don't know. Another thing which I notice right now is that if you look at this propeller and this propeller, this cone is actually quite steady and this one is not. So let me measure the frequency of the furthest of the right hand side motor, measuring here, and it gives 100 Hertz. I will show you. So I am measuring here. Oops. I will go this way. Hopefully not blocking anything. And you will see now you see nothing, which is not the intention, of course. Now why is this different than my previous measurement? It's at 23 kilohertz. The wiring is very unstable. Anyway, it proves that it does work, but is it stable? I don't know. An interesting thing is, by the way, that when you take a look at the registers, that from 1 to 64 there's a difference of factor 8. However, after that, so from 64 to 265, 56 and 1024, that is a difference of 4, factor 4. So now the question is, one step further with the 111, which does not work, is that actually 8192 or is it 4096? Either way, if it is 4, then you have, like I calculated here, a frequency of 15 Hertz, 15 something, or you have a frequency of 8 Hertz. And since I figured out that 30 Hertz is the lowest, these two are well below 30 Hertz, they are not working. So no use in trying that out, no matter which factor you choose. Having said that, the others are working. The point is though, since I can use a prescaler of 5 to get exactly 30 Hertz, what is the best thing to do? And then I really look at the prescaler range, which goes from, in this case, prescaler 5 is 30 Hertz to prescaler 1 is 31 kilohertz. Well, this one proves that prescaler 1 certainly works. because if 62 kilohertz works, 31 kilohertz works as well. And in the prescaler I get the safe range of 4 and 5, being 30 Hz and 120 Hz. So yeah, this is quite something. What I still have got to do is checking on pin 13, because so far I've only been measuring pin 4. And what the nice thing would be is if I use each frequency and check for the value of pin 13. Does it change? Does it not change? That is a very good point. And I think I'm just gonna measure it. I should, because if you want to complain about something, you have to get all data possible. So I think measuring pin 13 is all I have to do for this episode. Yeah, let's go to camera. So for the last part of this episode, I have connected a wire here in the breadboard to which is connected to the actual pin 13, and by a resistor and LED also to the ground. And here I have put the red probe alongside the multimeter, so I don't have to do anything except measuring, and it is at 14 between 14 and 18 kilohertz, and that is at a set frequency of 62,000 hertz. So that is not the same frequency. I'm going to change that to 976 hertz. And it is the same. So I'm going to change it to 62,000 hertz. No, 60 hertz. So I will have to change this now. And this is now 60 hertz. That would give only a 6 here. So going back to 900 hertz. And this obviously does not make any sense. So I'm going to make some inquiries about pin 13. And with that, the test for this episode ends. Thank you for watching. And as usual, if you like this video and my other videos, please allow advertisements in between the video segments, or you can go to my website, which is displayed which is shown in the start of the video and under the video, to use PayPal for a small donation to for my blog and videos. And this is obviously going to be continued.